I'm going to go over and address the common misconceptions and like FAQs I run into consistently setting up and building out these context operating systems for go-to-market. Now, instead of addressing these like one by one around like what tool should I use? Should I use Obsidian or Cursor or uh, stuff like that? I'm going to attack it from like more of a first principles perspective on just like a quick reminder on like how computers work. And the reason I'm doing that is my core belief is that Claude Code is so good, it's so effective, whatever you want to say, because it's simple, right? Genius has the least moving parts. And I'll get more into that in a second. But this space is a reminder on like how file systems work, why they work the way they do, how Claude Code works with them, and why this actually creates the like emergent dynamics we see. So we're gonna go over that, and by the end of this video, you should have like a much better understanding of basic computer science in a way that is hopefully like applicable and valuable to you using Claude Code for your own needs and go-to-market work. And it should be more intuitive to you, because rather than doing like point by point, question by question, I want to give you like the broad understanding and empower you that way. I think that's a better solution or better approach overall. So let's get into it. What I'm seeing over and over again is there's three things. There is confusion around what tool to pick, why to pick it, how, in regard to do you use Cursor? Do you use VSCode? Do you use Obsidian? How do you structure your context operating system? Why does it work the way it does? And these are good questions, and they're fair questions. The thing I think is, well, the thing I am, sorry, phrasing. What's actually going on is I think there are just broad first principle understanding or that would alleviate all of those questions and concerns. And the core thing I'm getting at is our apps. So your LinkedIn, Clay, iMessage, um, every single app you use pretty much on a day-to-day basis hides how computers actually work from you. They hide the file system. They hide, that's pretty much the main one. They hide the file system from you. You don't see why something, why a file is saved one place versus another, um, and how code is run, and all these other pieces of complexity that when in the pre-AI phase or pre-AI era, that hiding that abstraction was a net benefit to the user because you only needed to know how the interface worked and what to put in there. You didn't need to know anything of what it was doing on the back end. But the opposite case is not true. So because plain English is now code, you actually really need to know how a file system works. You need to know how to execute that code, right? That program, which is now plain English, mind you. It's not like Python or some specific syntax that is you have to learn. Plain English is code. And it's now more important than ever to understand the basics of how an operating system works, because you are now directly interfacing with it. That is all of the value. That is not all value. That is where a large portion of the value from Claude Code is derived from. And it's more simple than you think. And I know it's like, oh, great, another engineer telling us, telling us the thing they spend hours and hours and hours a day on is easier than we think. It's not the case. But like, let's start with this core axiom. Genius has the least moving parts. Simple is most effective. So those two things, right? It's really easy to overcomplicate a system. It's very hard to make a elegant, simple, and effective system that solves for the real functionality or real functionality that creates value. Let's say that. So more often than not, software engineering is an iterative process of adding a bunch of stuff and then removing the things that you don't need and honing down. Like a good analogy that I like is like, you know how they sand a surfboard down. The surfboard is inside that block of wood or fiberglass, I guess, whatever, and you're removing pieces iteratively. And the point I say that, the reason I say that is Claude Code is so effective because it is very, very simple. If you look at the kind of trend of AI development or AI engineering, because we're not talking about machine learning here, we're talking about large language model driven agents and all stuff like that. When it first came on, when the scene first exploded, it was vector databases and LangChain and like all of this shitty abstraction. In abstraction, I mean you're adding new things to the system, and it's getting more and more complex um, to try and solve for your outcome. But we haven't realized that those things actually added far more work than the value they brought, more often than not. Um, Cloud Code is so effective because there's like three big portions of it. It can just read and write from your file system. It can run commands, and it operates. It operates locally. So, and the next word that creates what is called emergent properties. So, emergent properties is 2 + 2 = 6. You get something that's greater than the sum of its parts. The like visual analogy of this is you see a flock of birds flying around. That is an emergent property of you having more than one bird, right? Birds flock together, and it creates something. It creates a flock of birds. Um, Having all of those tools and that functionality locally for Claude Code creates greater than the sum of its parts capabilities, which is by and large that plain English markdown files are now code. So to make that tangible and specific and understandable, and to give you that actual first principle understanding, today I'm going to just break down basic file system, how everything fits together, and talk about the different layers of abstraction and why it actually doesn't matter if your terminal is here inside of cursor, which I know we're looking at a lot right now, or if it's floating off in space in a different window. We're going to go through all of that and work through like the basics computer science, which we all learned, at least if you're not like someone who grew up totally in the um, app era where that all that was hidden from you. You all learned how file systems worked when you had to go save a Word document. I'm talking about my use case now, or my use case, Jesus Christ. My experience of being a kid in the early 2000s or in the 2000s of I want to save this file on the C drive. Where's the C drive? Oh, I have to go here, and here's my folder for me. I'm going to save it there, right? That it's like that level stuff. So we're going to start there, and hopefully that makes it a little more clear how Claude Code works and how to tool it and point it in the right direction to actually solve your go-to-market or your development or any use case you're actually using it for right now. Okay, so the first thing is what is a file system? We're going to close Claude Code, and now we're getting into the terminal. Scary, I know, super scary. I'm being facetious. We're going to hit clear, and now we are in a file system, right? We are in a terminal that has a file system. So I'll actually bump this out, or actually we'll do PowerShell. We'll pull this up, and this can be Windows specific, but the principles are the true across all modern operating systems. Windows, Linux, Mac OS are all file system based systems. So you see here, this is at the root layer of my user in this case. So when I open a PowerShell at my root layer, it's going to say only two things, and this is called a path. So it's the path to where you currently are in your system. Now, if I do directory, there's going to be a bunch of stuff in here. A lot of this is actually junk that I should remove. Claude has been throwing around a bunch of files. But you see here, it is by and large just like configuration files and other stuff like that. In fact, it's not even like where you would think where documents are or anything else like that, because Windows gives you another layer of abstraction in your file explorer, so you can navigate around without having to see this. So this looks flat, right? I'm going to exit out of this because there's too many things to list off properly. But if we go into this context operating system example, so a while ago I put out a context OS quick start guide, and I used like Jurassic Park as the fake business to work through. If we do dir here, and that just stands for directory, you're going to see .claude, 00 foundation, knowledge base. So the context OS is I design. You have your operational docs, right, with like your 00 foundation. Then you'd have like a 00 customer or 01 customer, 02 messaging, whatever your setup is. It's kind of dependent on what you need and how often you access specific files. And then a knowledge base, which is like a deep knowledge graph, like an actual imaginary graph. That's what the knowledge base is for. So you see here, we're looking at this directory like this. If I hit tree, you see now we see this like branching tree system. So this is what Claude Code is navigating up and down, right? That's going to go to, hey, Jacob told me to go to check the messaging. So it's going to use something called, there's multiple different ways to get there. But let's say it's going to do list. And it's going to see basically this exact thing. And it goes, oh, okay, the positioning is the foundation. I'm going to go in there, and I'm going to mimic this right now. So CD is change directory, the 00 foundation, right? And now I'm in there. I'm going to do I'm going to do tree, actually, so you can see. I'm going to see tree. Okay, messaging right here. So I'm going to do CD positioning, or I'm going to actually go messaging for my own example. CD messaging, and there's nothing in there. So if we go into here, right, nothing in there, nothing in there, nothing in there. We'll go actually to our knowledge base. So we'll go up. That is how you move up a directory. CD CD knowledge base. And then we're going to do dir. And then we do CD business. I think there's examples in there, right? Yeah. And then we're going to do list. Oh, what did React? What did you dir? List is a different command that does the same thing as dir. So this is how Claude Code is navigating around your directory at the basic level. So if we go to here, where is my Figma, right? We're going to do, first one is directory navigation. So that was super manual, right? That took me like a good amount of time relative to what I was trying to do just to move around 3 files or 3 directory levels in a terminal. Because Claude Code can generate all of these commands on the fly extraordinarily quickly, it suddenly becomes much more valuable because you can move up and down and go, yep, across these 1,000 files and go 1, 2, 3, 4, 5. Oh, and I should use what we're going to show next, like a keyword search. We're going to use grep, and actually I can just skip all the rest of these 950 files and just go right to this next section here. That is like this emergent agentic lexical search is what it's called, where it's combining the navigation directory, or excuse me, yeah, no, directory navigation. I flipped my words there. That capability along with keyword search, so grep, that's the next one, and reading a file, which is glob. Those are the tools that Claude Code has out of the box that create this emergent dynamic. So now we're going to get into grep next. Okay, so I put in this very leading prompt, or I'm basically telling it the answer. This is like a bad prompt when you're actually trying to find like net novel information, but I know what I'm looking for here, so I'm just gonna give it this leading prompt. And the reason I'm doing this in Claude Code is I don't want to have to write all my grep commands myself because that takes too much time. And that's, I think, one of the things that is an underrated explanation of why Claude Code is so valuable. It makes it so if you had infinite time to search across your entire knowledge base, your transcripts, internal working documents, CRM, data sets, everything like that, what questions would you now be able to ask that you weren't able to ask before? That's basically what Claude Code is giving you because of this emergent dynamic. So you can find files by pattern names, right? Oh yeah, excuse me. I think I said glob is read files, but it's a different type of search. So hey, I'm correcting myself. There you go. Grep content discovery, emergent patterns. Exactly. So you can do like the way I visualize it, the way I personally visualize it is imagine drilling for oil, right? They drill like a bunch of pilot holes. So they're like, no oil here, on to next grid. No oil here. Oh, there's a little bit more oil here. And you can like iterate down to eventually getting to like striking oil. And that's what this capability, these tools all come together to create. And it's like machine learning it's like gradient descent in machine learning, if you want like a more complex analogy. But I'm trying to simplify here. Yeah, triangulation. That's exactly the thing. So now I'm going to say to explain to make understandable. To show how simple functionality superior to over-engineered complexity. Again, leading prompt, not how it actually interfaces with. This is not how I actually interface with my context OS if I'm trying to find net new insight. So this is a good example here. It knows this is a Jurassic Park context OS because if we go down to this right here, this MD file, this is always injected into Claude Code when it starts up. So this is like your governing canonical rule set. It tells it what it is and how to work together or how to interface with that given app or context OS, whatever you're telling it to look against. This is always given to Claude. So you should make sure in your own system that this is really, really in depth and well thought out. Because an error in here compounds across multiple sessions, and you either have clarity in this, you either have clarity in this file, which guides all future sessions, or you have errors in this, like you have basically ambiguity. We'll call it clarity versus ambiguity, and you either compound positively or compound negatively. So going back to letting it run this search. I'm doing this live, by the way, so I'm just reading this for the first time myself. Here we go. So that's how it knew to search against Raptor. Do Control O. Now we're seeing the searches. So this hides it from you, right? Pattern, Raptor, and it's telling it, all right, I want to find this keyword in this area, and tells it, hey, this is where I found this line. And it gets the area around it. In this case, it was telling it, like, when you find Raptor, give me the lines before it and the lines after it. At least that's what I think it's doing right now. Yeah, exactly. It's saying, hey, in this MD file, Raptor is, I don't know where it is, somewhere in here. Yeah, right there. So all of these are then being injected into the context window, and it's far more token efficient, and they can iterate much faster across the search, giving it that emergent capability to almost act like it's thinking like a human being, even though it's not, right? It's doing this sophisticated information lookup. Exactly. Yeah. So we're built from simple parts that combine this. And then Bash is even more valuable because previously, if you wanted to run a Python script or some sort of let's look at Python script. Let's say you want to do data analysis on a data set, and you need to use pandas. You would have been doing that in Jupyter notebooks, which is basically you have Python and you can do like stuff down here, like a Python runtime, and then you can do other stuff separately. So you have like multiple different areas to run separate apps. Or doing it locally. The point being, like, there's a lot more overhead yourself. Now, because it's inside of the context window in here, um, the agent can write and run that command for you and then push out that information to your local file system. So it's just persisted outside of the context window. And that is what allows any context operating system to become this compounding intelligence asset. Because once you solve a problem once, you can say, hey, Claude, I want to save how we solved this persona analysis. Let's save this as a skill. And then get pushed up into skills right here, which is, again, a markdown file because plain English is now code. So we'll do and y. And I think this would be the last thing we cover. So let's dive into this. You see here, I'm going to do question O, right? ls raw context. We're pulling in, it's listing the directory, and it's being able to see everything in here. So an important distinction is in the syntax here. This is basically what I just showed you with commit change directory, that's CD and tree, except because Claude Code is like its own separate application, it's writing and running stuff using Bash, which is using Unix syntax. So same fundamental principles, just a little bit different. I had to let someone in. But look at this. So it's now actually kind of messing up because I didn't give it tight enough instructions to say, hey, don't try and go and do Git, which Git is version control software. It's basically how we take a snapshot of an application at a point in time, and then you can have multiple snapshots to make sure that if you make a change to something, you can just roll it back, or you can branch applications into different versions, and that allows asynchronous. That is what enables asynchronous collaboration. So I'm going to say no, not relevant, stay on task. So this is what I mean by either ambiguity or clarity compounds. This is not, or because I gave it a pretty actually ambiguous, ambiguous, maybe. Prompt that, because I gave it a prompt without like very clear constraints, it went off and it got sidetracked. When you are like engineering these context architectures, you have to be like far more specific than you think you do. Otherwise, you get stuff like this. But I think I've got my point across. At least I hope I have. Let me check my notes. Yeah, let me go back to this basically. Directory navigation. And we do grep glob. And finally, we'll say like read file, basically. It's not fully accurate, but. So these are like different layers of tooling that all build on one another to create something bigger than the sum of its parts. All of these fit together to create something called Agentic. Let's go search. And we'll say that's bigger, whatever. I know this is bad visual. And this all depends on, if we go to here, oh, see, look at this. Now we're getting an advanced search pattern. So it was able to pull enough information, pull enough context into this window from this Claude.md and all the other files it searched across here to say, hey, this would be a good demo. And what is it demoing? It's going to use something, it's going to grep. And then this pattern right here is basically a pattern to search for emails. I know it doesn't look like it, but this is what I mean by you get into syntax. So I could have said, hey, find me emails, and it would translate that into this syntax pattern to find those emails and answer that question: who is mentioned the most in emails? And I can just do similar commands, so then it can go search on its own. And there you go. See, it's actually printed out an answer here, right? My name is Muldoon is the most, Hammond, Nedry. Now, this doesn't look right to me. So this is where it also comes down to you fundamentally. It comes down to someone who has an understanding of the system. There's no way this guy's name, Muldoon, is mentioned 711 times. And it's actually caught that itself. But this is to show the systems are not perfect. It's going to make mistakes, but that's why we have guardrails and attribution systems as a part of this. And then it ran another one and fixed it. Oh, that was actually artifacting error, like a UI error. So 711 times. That makes more sense. I think it's funny that's actually cosplaying. Yeah, that's a red flag. Here we go. This is a good breakdown. Read file, filter, order, count, rank. So this is how it's navigating across this entire context operating system and creates greater than the sum of parts capabilities. So going back to my crappy diagram here, right? These tools, read, grep, glob, directed navigation, creating this emergent agentic let's go search, right? It depends on this fundamental core functionality of computers that has been around since we created digital computers. It's actually more simple than all of the crazy, you need a vector database, you need lane chain, all of that stuff. It's more simple and thereby more effective because there's less moving parts for things to break, for things not to work. It is just that simple genius. So then finally getting back to the original thing I said I was going to cover around should I use Cursor or Obsidian or VSCode or anything like that. I want to reframe it. It's not a tool question. Fundamentally, it doesn't matter because instead of apps, you are now the primary working unit that is now important is files. It's files over apps. So if I take this, I'm going to copy this and steal for myself. It's going to be this is our file system. And by the way, this is how it's always been. It's just that, we've had, our operating system, like a Mac OS or Windows that hides all of this from us. It hides this fundamental, terminal from us because it's easier for us to click around with UI, anything like that. You look at old computers, it was all terminal. The huge innovation was that operating system, which made the barrier to entry much lower. It made it so more people could use computers without actually having to understand all of the complexity of a file system. But now we are moving away from, so that's the next layer would be like your applications, which had even more layers on top of them, or had even, which was another layer of abstraction. So we think we're used to working at the application layer. So we're like, oh, what app should I use? The most important layer now is actually the file system, because now our application, Claude Code, is going to get rid of, let's say, I'm going to say this is cursor, Obsidian, VSCode, whatever. By the way, so cursor and Obsidian are both called, not cursor and Obsidian, cursor and VS Code are called integrated development environments. That's what that class of application is called. They are specialized, or they're different than a traditional like consumer application, because they're meant to kind of go work through, all of the stuff here around. I'm waiting, I guess. This like unnecessary abstraction when you're doing development work. But now, because plain English is now code, this direct connection, right, to our file system, we're just using Claude Code Agentic Let's Go Search to make doing all of this stuff far more easy. And we're not actually bypassing the operating system. This is maybe not the best analogy. You want to get pedantic, it's like this, and then the kernel, and then kernel is like what, firmware, and then finally, the point I'm trying to make is like there's layers all the way from the most software that you interact with today, and all the way down to like the actual computer CPU running the zeros and ones. There's like layers of abstraction, and each layer hides the stuff below it, so you only have to work with that new layer. But we are removing unnecessary layers of abstraction now, because we've like moved that complexity of like running and writing those scripts to Claude Code and other agents that can read and write on our files, on our file systems. So the fundamental question of what tool to pick, don't think about that. Think about the question of like, how do I want to organize my files so it's optimized for my agents and for myself, that's intuitive for your own understanding, to work in this file system. That's how all of this works. Yeah, I think that is pretty much everything I wanted to cover. This is a more impromptu video because I was seeing these questions come up over and over again, and they're good questions. I understand where they're coming from. I just wanted to almost invert the question. And I think that's a much more valuable and useful place to come from. And it's also more intuitive once you remember, like, hey, like, we were all taught this stuff as kids, or at least I hope you were. If you're not, like, hopefully there's a good crash course. And we're just removing stuff that is no longer valuable or useful to our actual needs. So, yeah, I hope you learned something from this. I hope it was valuable, and I hope you have a great rest of your day. Bye.